This next example uses very, very similar ideas, so the method is very similar, but some of the algebra that we need to process is a lot more fiddly and complicated, so we're going to have to be very, very careful in the process of doing that. So we're asked to find the binomial expansion of the cube root of 8 plus 16x, all divided by 1 plus 3x. So firstly, let's realize that this is the same as saying 8 plus 16x all to the third divided by 1 plus 3x all to the third, which again is equal to 8 plus 16x to the third, and then 1 plus 3x to the minus third. Well, notice what we're going to have to do here is we're going to have to do two binomial expansions. We're going to have to expand this expression out here, and we're also going to have to expand this expression out here. And then we're going to have to multiply the two results. So let's start by multiplying out the right-hand one. I'm going to do that in red as a little aside, because I think it's possibly slightly easier to deal with. So 1 plus 3x to a minus a third. Well, using our general binomial expansion in this blue box here, we have 1 plus n lots of x. Well, the n is minus a third lots of 3x here. And then we have minus a third, and then n minus 2 is minus 4 thirds, all over 2 factorial lots of 3x squared. And then finally we have so I'm going to do each of these separately first. So let's start in red with 1 plus 3x, the power of minus a third. I'm going to use our general binomial expansion with n equals negative a third and 3x in the place of x. So this is 1 plus minus a third lots of 3x plus minus a third times minus 4 thirds over 2 factorial lots of 3x squared plus minus a third minus 4 thirds minus 7 thirds over 3 factorial lots of 3x cubed, and we only want up to the x cubed terms here. Well, doing some simplifying, what do we get? We get 1 minus x, and then here, well, we're going to have a 3 squared, but the 2 3's on the denominators is also 3 squared, so they cancel. So we get negative 4 times negative 1 divided by 2 factorial, which is just plus 2x squared. And then finally, we have a 3 cubed. We also have a 3 cubed on the denominator, so they cancel. So we have minus 1 times minus 4 times minus 7 over 3 factorial. Well, that is going to be negative the 2 from the 3 factorial cancels with the factor of the 4, so this is going to be 14 over 3 lots of x cubed. Let's similarly deal with 8 plus 16x to the power of the third, and let's do this in blue. So 8 plus 16x to the power of the third. Well, notice here that this 8 is not a 1, and to use our general binomial, we need to make sure we do get a 1 here. So let's take a factor inside this bracket of 8. And then notice this is 8 to a third, 1 plus 2x to a third. Well, what is 8 to a third? That is 2, it's the cube root of 8. So this is 2 lots of 1 plus 2x to the power of positive a third. So now we can apply our general binomial expansion. This is 2 lots of 1 plus nx, which is a third, times 2x, plus a third times minus 2 thirds over 2 factorial lots of 2x squared, plus a third times minus 2 thirds times minus 5 thirds over 3 factorial lots of 2x cubed plus higher order terms. And again, doing a bit of simplifying, this is equal to 2 lots of 1 plus 2 thirds of x plus cancelling a factor of 2, this is cancelling a factor of 2, we get negative 4 over 9x squared, and here we get cancelling a factor of 2 plus 5 times 8, so plus 40 over 3 to the power of 4, 81x cubed, plus our remaining terms. So we've got these two things expanded individually. So now we need to multiply these two together. So our original expression here, so we know that the cube root of 8 plus 16x over 1 plus 3x is equal to this multiplied by this. So 2 lots of 1 plus 2 thirds of x minus 4 ninths of x squared plus 40 81sts of x cubed, and the higher order terms multiplied by 1 subtract x plus 2x squared minus 14 over 3 x cubed plus higher order terms. And now we need to multiply this out, and this is quite a complicated thing to multiply out, but we're going to be strategic about it, because remember that we only want the first 4 terms, so we only want to get terms up to and including x cubed. So let's start with this 1 here and multiply it by everything on the right hand side. So we get, well, we have our 2 lots of 1 multiplied by all of this, which is just exactly the same as it was before. Okay, but now let's deal with 2 thirds of x multiplied by all of this. So 2 thirds of x times 1 is 2 thirds of x. 2 thirds of x times 2x cubed is 2 thirds of x multiplied by minus x is minus 2 thirds of x squared. 2/3 of x times 2x squared is 4/3 x cubed. And we don't need to do this next one, because if we do 2/3 of x times negative 14/3 x cubed, that's an x to the power of 4. And we know that we're only going up to x cubed terms. Okay, so what's next? Well, next we should do negative 4/9 of x squared multiplied by all of these terms. But remembering, we only want to go up to the x cubed terms. So we get times 1 minus 4/9 of x squared times by negative x gives us positive 4/9 of x cubed. And then we don't need to do any more there, because the next term will be an x power 4 term, which we can ignore because we're only going up to the x cubed terms. And finally, we need to multiply 40 over 81x cubed by all of these. But actually, the only one we need to do here is the 1, because multiplying with those other terms will give us x power 4, 5, 6, etc., which we're not interested in. So this is just add 40 over 81 x cubed. And then all our other terms are going to be higher order terms. So what's left? Well, what's left is just to collect like terms. And you might want to try and do this yourself. It's a little bit fiddly. You might want to use a calculator. But what do we get? Well, we have two lots of 1. Then if we take the x terms, we get negative x plus 2/3 of x, which is minus 1/3 of x. We take the x squared terms, we get from here, here, and here, we actually get 8/9 of x squared. And if we take the x cubed terms, here, you end up getting negative 194 over 81 x cubed. And then higher order terms. And expanding this out, we get 2 minus 2/3 of x plus 16 over 9 x squared minus 388 over 81 x cubed plus the higher order terms. And just to finish this off, remember we are also asked, when is this valid? Well, we need to be a bit careful, because we did two different binomial expansions here. And this first one was valid when 3x was between minus 1 and 1, or x was between negative 1/3 and 1/3. And the second one was valid when x was 2x was between negative 1 and 1, so x was between negative 1/2 and 1/2. So when is this whole thing valid? Well, both of these have to be valid. So we want to take the most strict criteria. So which of these criteria is most strict? Well, the most strict criteria is this one, the smallest range of x which this is valid. Because if x is between negative 1/3 and 1/3, it is definitely between negative 1/2 and 1/2. But the converse is not true. If x is between negative 1/2 and 1/2, doesn't mean an x between negative 1/3 and 1/3. So this whole binomial expansion is valid when x is between negative 1/3 and 1/3.